So in this problem, we need to prove that a squared b squared multiplied to a squared plus b squared, that's equals to 1 whenever we have a cube and b cube given by this trigonometric expression. Let's begin. So let's start with whatever we have been provided with. So here we have a cube equals to cosecant of theta minus sine theta, and we have b cubed given by secant theta minus cosine theta. What we can do is we can simplify the expression on the right hand side of a cube. So cosecant theta, we know that the cosecant function is the reciprocal of the sine function. So cosecant theta will be 1 over sine theta minus sine theta. So this is going to give us 1 minus sine squared theta divided by sine theta. And 1 minus sine squared theta, so that's simply cosine squared theta. So cosine squared theta over sine theta. So a cube can be also expressed as cosine squared theta over sine theta. Now coming to b cube, so b cube is secant theta minus cosine theta. When we know that secant theta is the reciprocal of the cosine function, so 1 over cosine theta minus cos theta. Combining them, we get 1 minus cosine squared theta divided by cosine theta. The 1 minus cosine squared theta, that's sine squared theta. So we have sine squared theta divided by cosine theta, which is the value of b cube. Now that we have a cube and b cube, what we'll do, we'll divide a cubed with b cube. So let's divide a cube with b cube to get, we have cosine squared theta, which is divided by sine theta. This is the value of a cube, and we're going to divide it with b cube. So let's do, since we're dividing by b cube, we'll multiply it with the reciprocal of b cube, which is cosine theta divided by sine squared theta. So this is going to give us cosine cubed theta divided by sine cubed theta. So we obtain that a cube over b cube, that's equals to cosine cubed theta over sine cubed theta. So if we take the positive cube root on both sides, then we're going to get a over b equals to cosine theta over sine theta. So we will keep this aside. We'll come back to this in a moment. Now we need to show that a squared b squared multiplied to a squared plus b squared, that's equals to 1. This is what we need to show. Now we'll begin from the left hand side. So on the left hand side we have a squared b squared multiplied to a squared plus b squared. So let's do one thing. We are going to multiply and divide with ab. So when we multiply a squared b squared with ab, we're going to get a cube times b cube. And then we'll also have to divide by ab. So we're going to divide a squared plus b squared with ab. That's fine. So now we have a cubed times b cube multiplied to a squared divided by ab plus b squared divided by ab, which is going to be equals to a cubed times b cube multiplied to a over b plus b over a. Now we have the value of a cube. So we have obtained the value of a cube is cosine squared theta over sine theta, and b cube is sine squared theta over cosine theta. Let's use these values. So we're going to get, so in place of a cube, we have cosine squared theta divided by sine theta. In place of b cube, we have sine squared theta divided by cosine theta, whole multiplied to a over b. So a over b is the ratio cosine theta over sine theta plus b over a, that's the ratio sine, that's simply the reciprocal of a over b. So we're going to have sine theta divided by cosine theta. Now we can cancel out one cosine theta from the numerator and the denominator, and also one sine theta from the numerator and the denominator. So we have cosine theta times sine theta, and if we combine these two terms within the parentheses, our common denominator will be sine theta times cosine theta, and in the numerator we're going to have cosine squared theta plus sine squared theta. So cosine theta sine theta will get factored out from the numerator and the denominator, and we are left with cosine squared theta plus cosine squared theta in the numerator, and this value is an identity with a value of 1. So this is the right hand side. Hence we have successfully showed that our expression a squared b squared times a squared plus b squared, this equals to 1 whenever we have the condition that a cube is given by cosine squared theta over sine theta. This is actually the reduced form, and b cubed is sine squared theta over cosine theta.